Okay, so this review is not difficult at all. What we first need to know is that our trig functions are so, ka, toa. So the whole majority of this review is just being able to use so, ka, toa. So if we look at number 1, it wants the sine of A. So what I'm going to do is circle A. And so we know that this side here across from the 90 is the hypotenuse. The one across from the 90 will always, 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 always be the hypotenuse. The one across from A is called the opposite, and the one right next door is called adjacent. So the sine of A, sine means we take the O number, there's the O number, it's a 3, over our H number is a 5. So the sine of A is 3 over 5. No calculator, we're just writing the ratio. A ratio is a fraction. We just leave it as a fraction. So cosine of A, let's see, cosine is adjacent, so the adjacent is 4 over hypotenuse. Hypotenuse is 5. Then finally we have tangent. Tangent is opposite over adjacent. Okay, so we're going to do the same thing with number 2, but in number 2, we're missing a side. I don't have a hypotenuse. So what you learned a couple of chapters ago is something called Pythagorean theorem, which says that a squared plus b squared equals c squared. So 25 plus 49 equals c squared. So 74 equals c squared. So c equals the square root of 74. Yep, that's it. Okay, so now we can go through and write down our pieces. So again, it wants it from angle A. Here's angle A. So sine is the opposite side. Here's hypotenuse. Here's adjacent. So sine is opposite over hypotenuse. 7 is our opposite. Square root of 74 is our hypotenuse. Cosine is adjacent. Oops, it's an A for adjacent. So cosine is adjacent over hypotenuse. And then finally tangent from sine A. Tangent is opposite over adjacent. Very pretty. Okay, so go ahead and do the same thing for number 3. I'll help you find your hypotenuse. So you have 12 squared plus 10 squared equals c squared. So 144 plus 100. So c squared is 244 square root. 244 breaks down, that's 2 and 122, which is 2 and 61. So this is 2 square root of 61. I'll start you off. So it says b this time, so sine of b. So here's b. Across the middle is called the opposite. Across the 90 is called the hypotenuse. And right next door is called the adjacent. So sine of b is the opposite, which is 12, over hypotenuse, which is 2 root 61. These are both numbers. 12 divided by 2 is 6 over the square root of 61. If your teacher does not want a square root below, then you just give it to the top and the bottom. So that leaves you with 6 root 61 over 61. This here is technically the answer, but if they want square roots not to be on the bottom, then we have to move it to the top. So do the same thing with cosine. So cosine is adjacent, which is the number right next door, over hypotenuse. And then tangent is opposite over adjacent. Okay, number 4 is beautiful. Let's just knock out number 4. So in number 4, it says B. Here is B. Opposite is across. Hypotenuse is across from the 90. Adjacent is the final one. Sine is opposite over hypotenuse. those numbers will reduce. I can cut them in half, so that's 12 over 13. Cosine is adjacent over hypotenuse, so that's 5 over 13. And finally, tangent is opposite over adjacent, which is 12 over 5. Not too bad. All right, next. It says, find the value of each variable below. Round your answer to the nearest 10th place. So what we have here is there's a lot of things going on. So we need to figure out what we want to start with. Murphy, stop. So I'm going to say, let's start with Z. I'm going to ignore this, and I'm going to ignore this, and just try to solve for Z. So again, at the top, I'm going to write so, ka, to, Murphy, stop. So this here, I have an opposite, and I have a hypotenuse. So that means I'm going to use sine. So I'm going to say sine of the angles, which is 35, equals opposite, which is Z, over hypotenuse, which is 8. So to solve for Z, this is saying Z divided by 8. The opposite of division is multiplication. So I'm going to times 8, and I'm going to times 8. So now in your calculator, you're going to type in 8 sine 35. Make sure your mode is in degrees. If it's not in degrees, it's not going to work. So my mode has to be in degrees. So I can't show you the calculator through my iPad screen, but I can type it in myself. So I'm going to go to mode. I'm going to change it to degree. And I'm literally going to type in 8 sine 35. And it says round it to the nearest 10th place. So that's going to be 4. Ugh, hold up. So what I know is that Z is 4.6. Okay, so now I can solve for Y. If I have two sides of a right triangle, I can use Pythagorean theorem. So I can say that 4.6 squared plus Y squared equals my hypotenuse squared. So your leg squared plus your leg squared equals your hypotenuse squared. So I can solve for Y that way. I could also have used cosine, because from an angle I have an adjacent to solve for Y, and I have a hypotenuse number, so I could have used cosine. Or we could just use Pythagorean theorem. So 4.6 squared is the number 21.16 plus Y squared equals 64. I'm going to subtract. So that leaves me with Y squared equals 42.84. Second square root. So my Y value, I got 6.5. Okay, so I solved for Z by using trig. I ignored all of the other sides, and I solved for Z that way. I solved for Y by doing Pythagorean theorem, because I had two sides of a right triangle. So now the only thing I have left is X. I'll move it up here. So to solve for X, what we know is that we have two sides, or two angles. So 90 plus 35 is a total of 125 degrees. So if these two make 125, all of them will make 180. So 180 minus 125 is the number 55. So X, the angle, is 55 degrees. Okay, so we use trig to solve the first one. We use Pythagorean theorem to solve the side. And then we just use the fact that angles add to 180. Okay, so let's look at number 6. So again, in number 6, I'm going to solve for a side. Let's pick a side, any side, I don't care. Let's solve for Y. So I'm going to ignore those two for right now. So to solve for y, what I know is here's my angle. This across from it is called the opposite. The one next to it is called the adjacent. So to set up the trig, opposite over adjacent right here it says is tan. So it's going to be tan 65 equals opposite over adjacent. To get y by itself, we multiply, so times 4 and times 4. If the letter is on top, then we multiply to get it by itself. So in the calculator, 4 tan 65 is the number 8.6. So I just found out that y is the number 8.6. Now that I have two sides of a right triangle, I can solve for z using Pythagorean theorem. One leg squared, so 4 squared, plus the other leg squared equals the hypotenuse squared. 4 squared plus 8.6 squared, and then the square root of that, so this is 89.96 equals z squared. Square root both sides. And I get the number 9.5. So my z value is 9.5. Last but not least, we have an angle to solve for. So to solve for this angle, we know that one side is 90 plus the other angle is 65. That gives me 180 minus 155. So my angle is 25. I added these up, I subtracted it from 180, and it gave me that angle measure. Okay, let's look at number 7. Okay, so 7 is a little bit different because I'm going to erase this, it's out of my way. So in number 7, what we have here is there's no angles. All we have is the 90. That's not helpful. So I'm going to start by solving one of those angles. I'm going to ignore you, and I'm going to ignore you, and I'm just going to solve for z. So to solve for z, what I know is the opposite, and I know the hypotenuse. So to solve for z, I can do opposite over hypotenuse is sine. So sine of z equals the opposite over the hypotenuse. To plug that in the calculator, you press second, it's the blue button, sine 6 over 10. So anytime you're plugging in to get an angle, you have to use the blue button first, second sine. So that gives me the number 36.9. So z is the number 36.9. Okay, so now that I have that angle, I have lots of options. So to find y, I can do 36.9 plus 90, and then subtract that from 180, and that gives me the angle 53.1. To get angles, we subtract them from 180. To figure out my missing side length, I can use Pythagorean theorem. So one leg plus the other leg equals the hypotenuse. 36 plus x squared equals 100. Ooh, whoops. Minus, oh my goodness, stop. Stop. Minus 36. Oh my goodness, this is gonna kill me. Minus 36 minus 36 is 64. How nice. So that means that x is 8. Okay, so we solved for each piece. So do the same thing with number 8. So I'm going to set you up. So go ahead and let's say we're going to take away this guy, and we're going to take away this guy. So to solve for x, we have an opposite and we have an adjacent. We don't have a hypotenuse. So that means that we're going to set it up as tan x equals opposite over adjacent. That gives you the number 56.3. Okay, so now that you know that that's 56.3, you can solve for y because they'd make 180. And then you can solve for z by using the Pythagorean theorem. Next, whoa, out of order. What happened? Okay, now we're looking at 9 and 10. 9 and 10 are easy. They're like really easy. So in 9 and 10, we have an angle, we have an opposite, and we have a hypotenuse. So opposite of our hypotenuse is sine. So it's sine of your angle equals opposite over hypotenuse. So this one's a little bit different because when there is a number on top, what you're going to do in the calculator is that number gets to stay on the top and you just bring the sign underneath. So it's 53 divided by sine 21. And that's going to give you the number x equals 147.9. So in this one here, the number, if you have a number on top, keep it on the top and then divide. If the number is below, that's when you would multiply. So let's look at this one here. So in this one, we have an angle, we have an opposite, and we have a hypotenuse. Opposite over hypotenuse is sine. So it's sine of your angle equals the opposite over the hypotenuse. The number is not on top, so it doesn't get to stay there. The number is below. This is like saying x divided by 126. To undo division, we have to multiply. So in the calculator, I'm going to type in 126 sine 59, which leaves you with 108. Okay, moving on. I still don't think I have 11. Let's see what I have here. Oh, hi 11. Well, that's awkward. I'll just put them both in the same page. That's silly. I found it. Ooh, that's really annoying, actually. Let's just move you over there. We'll move you here. Okay, number 11. So it's the same. We're just doing regular trig. So these are actually easier than those other ones. So same thing. Find your angle. We have opposite, and then next to it is the adjacent. We don't have a hypotenuse, so we're not using h. Opposite over adjacent is tan. Let me put it up here so we remember. So, So we have opposite over adjacent, which is tan of 65 equals the opposite over the adjacent. What we said is if the number's on the top, it stays on the top. And in the calculator, you're going to write 91 over tan 65. And that leaves you with the number 42.3. Okay, number 12. Opposite, adjacent. Again, tan of 23 is the opposite over the adjacent. To solve, we need to get x by itself, so I'm going to times 463. I'm going to times 463. This is a multiplying, so that looks like it's a multiplication sign. That's the way to remember it. If you see like a multiplication sign on top, the x, if it's on the top, that's when you multiply. So in the calculator, I'm going to type in 463 times tan 23, which is 196.5. Number 13, I have an angle, I have an opposite, and I have a hypotenuse. So that's sine. So sine of x equals the opposite over the hypotenuse. When we're solving for an angle, that's when we're going to do sine. So the negative 187 over 136. So that's second sine 87 divided by 136. That's number 39.8. So x is 39.8 degrees. One more like this. We have an angle, we have an opposite, and we have an adjacent. Opposite over adjacent is tan. So it's tan of my measure, which is x, tan of my degree, equals opposite over adjacent. Second tan, 18 over 59. That leaves me with 16.97 degrees, which could also round up to 17. Okay, answer to number 14. Not too bad. Let's try to find 15 and 16. Let's see, where are they at? Here they are. Hello, 15 and 16. All right, number 15, we have an angle. We have an adjacent because it's next to it. We have a hypotenuse because it's across from the 90. So that leaves me with cosine of 72 is the adjacent over the hypotenuse. Solve for x. If I multiply, if there's an x on the top, it's a multiplication sign on the top is what it looks like. So that means we multiply. So we multiply this times 475. 475 cosine of 72 equals 146.8. Last but not least, here's my angle. I have an adjacent and I have a hypotenuse. I don't have an opposite. So again, it's cosine. This is x equals adjacent over hypotenuse. If we're solving for an angle, we press second cosine 265 divided by 371. 44.4. Okay, let's move to 17. Okay, in 17 we're doing the exact same thing, but this time, instead of having it as a picture, it's going to have it as an application, which is not that hard. So in 17 it says, given the rectangle, find the measure of angle 1. So this rectangle doesn't matter. I don't want rectangles, I want triangles. So I'm going to ignore that rectangle completely. So I have angle 1 that I'm solving for. I have an opposite, and I have an adjacent. So that leaves me tan of some angle I don't know equals opposite over adjacent. Second tan, 5 over 30. So my angle is 9.5 degrees. Very small little angle. That's silly. All right, 18, it gives me a picture. We've got a chair, lift on a ski slope. Here's my angle. So this is the opposite. This is the hypotenuse. So that's sine of 28 equals the opposite over the hypotenuse. To get h by itself, the opposite of division is multiplication. And that leaves me with a number, 2178.3. Next. This time there is no picture, so we need to draw it. It says we have a ladder that leans against a wall. Here's the wall. Here's the ladder, here's the ground. Make this little house. Here's the wall of my house. Here's the ladder. And here's the ground. There you go. Cute little house. All right, it says a 20-foot ladder, ladder leans on the house, is against a wall so that the base of the ladder, the bottom of the ladder, is 8 feet from the base of the house. What angle does the ladder make with the ground? There's the angle with the ladder and the ground. So I have an adjacent and I have a hypotenuse. So cosine of my angle equals adjacent over hypotenuse. When you solve for an angle, you press the blue button, second cosine, 8/20 is the number 66.4. Number 20, Kira is flying a kite. Here's your little kite. Okay, she's flying a kite and has 250 feet of string. There's her string. If the string makes an angle of elevation of 27 degrees to the ground, so here's the ground and here's her string, so this is 27. Anytime you see angle of elevation, it's always this corner angle right here. How high is the kite off of the ground? How high is that kite off of the ground? Her string was 250 feet. So we look at our angle. We have an opposite and we have a hypotenuse. That's the word sine. Sine of 27 is the opposite over the hypotenuse. So that's 250. Sine 27. So the answer to number 20 is 113.5. Last page. Close to the last page at least. 21. A pilot spots a target at an angle of elevate, whatever. It's always a right triangle. We're going to draw a right triangle. So a pilot spots his target at an angle of depression of 15. Just put your angle in the bottom corner every time. Makes it easy. When he is flying at an altitude, altitude means it's this length right here. That's how high he's flying in the air. Like here's his little airplane. So altitude is always the height from the ground, straight up. What is his range to the target? The range is the direct distance from the plane to the target. So what is that direct distance right there? So in this here, we have an opposite. So opposite over hypotenuse, that's sine. So sine of 15 degrees equals the opposite over the hypotenuse. When the number is on top, it stays on top. 15,000 divided by sine of 15. That leaves me with a very large number. So the answer x equals 57955.5. So he is 57,000 feet away from his target. 22. While standing on the top of San Jacinto Monument, whatever, let's try it. Always a right triangle in this chapter. While standing on the top of San Jacinto Monument, which is, here's the monument, it's 570 feet from the ground. During a reenactment, Travis spots the Mexican army at an angle of depression. Just put your angle in the corner every time. Directly between the Mexican army and the base of the monument is the Republic of Texas, heading from the east at an angle of 43. How far apart? Let's see. So this recording is about to run out. I have 1 minute for this one, but I'll post a second one. So I can't finish this in a minute. I'll continue 22 in the next video.